Okay, so, right, if we tried to make movement with get key down, that would mean the player would have to press and release and press again every time he wanted to move a little bit. Not very great. World space versus local space. I like to think of world space as north, south, east, and west. These things don't change no matter which way you've spun around. But local, I like to think of it as my right, my left. If you ever feel like your objects are moving in a really, really strange and goofy way, try changing the movement to be in world space. It's a very common mistake. And if we multiply something, the last review question, if we multiply something by time dot delta time, it converts the value to units per second. And it also, I feel like all of my classes are bleeding together. I'm not sure if I talked about this, but it also equalizes move speed on all machines. So my toaster at home and the supercomputer at the CERN laboratories would play this game at the same speed. Are there any questions about the review? Any things you want clarified? Any things I didn't really talk about or explain? Ah, um, so you could say get key, and we're looking for the S key. So every frame that the S key is pressed down on the keyboard, this would return true. Mm-hmm. So I guess I should say, yeah. And get key down is it just got pressed, just now. I feel like my handwriting looks better up there than it does on here. I don't know why. Some strange trick of scale, perhaps. So, I think that's it. Are there any more questions before we get into the plan for today? I see some head shakes. That's good. And this Photoshop file will be up on the, what's it called? Canvas. So we've got a couple things I want to cover today. And I didn't list them in order because I didn't consider what order we should start with. But I think I'd like to start with public versus private. Does JavaScript have a public and private? Or is everything public? Mm-hmm. Um, that is basically the opposite of public. So in C sharp, actually, before we define what they are, let's just talk about how they're used. In C sharp, every function and variable must have a protection level. And we're going to talk about two of those protection levels, public and private. They're the main ones that you need to know about. There's one more, but that is not useful for our purposes in this course. So private, this is the default. If you do not declare a protection level, C# is going to assume, hey, this is private. So let's talk about what each of these mean. So public means this variable or function, we'll just say can be accessed. From other components. And private essentially means nobody can touch it. So we'll say only this component can access. Can anyone think of why you would want to make something private? To say that, hey, other people can't touch this variable. Yep. Yep, important things. Things you want to protect, essentially. One example I always like to use is in games, I always make my health private. Because I don't want some other script saying health equals 1 billion. I might have a maximum health that I am clamping it in between. I might have certain rules about how health gets taken away. Maybe I have armor. Maybe I block some damage that I take. And if this is public, that means any script can just say, hey, that health is -1 now. But if it's private, it means these other scripts will get an error if we try to access that variable. Honestly, I would say when you're making games, almost when you first start making games, almost everything can be public. As long as you're working with a team of people and you all know like the project, it's a small project, it's fine. But once the project gets bigger or once you have more people, maybe you hit something small like 20 or 30,000 lines of code, then you want to be a little bit more careful about who gets to access which variables and functions. Let's put one more. Whoa! Radial menu. I don't want you. There we go. So in Unity, there's one more bonus to having something public, and that is you can edit this variable in the inspector. Yep. Whoa. Public and private. So this ties into the first thing that we're going to do today. And I'd like to talk a little bit about it before we jump into the code. Actually, the code's not that daunting. But it's linking objects, or linking components and game objects. So the idea is, let's say I have some script here. And this script wants to know about a cube in my world. So this is a C# script. The question becomes, how do we get this script to know? Maybe we have 2 cubes in our world. How do we get this script to know which cube I'm talking about? We could give it different names. That's very true. And usually you would want them to have different names. That's a good point. But Unity gives us this really easy thing. If we, in the C# script, we made a public game object of something, we'll just give it the name target. Nice and generic. So in our C# script, we have this public game object target. Let's actually see what happens. I'm going to make a new script, and we'll call this linkage practice. That's interesting. Editor, metal support disabled. I think it's talking about Mac's rendering API. I think Mac has a thing called metal. That's not what I want. There we go. Giant text. I'll fix my curly brackets. So just as a quick example, we'll do a private float unseen, and we'll also do a float unseen 2. So we should only be able to see this target in our inspector. Let's drop this script onto a game object. Drag and drop. There we go, cool. So we can see here, it only shows the public variables in the inspector. And we have 2 options when we want to link. We can drag from the hierarchy. So if I wanted to link the directional light to our target, I can drag and drop it here. Now this script, whenever we talk about target in the script, it's pointing to this directional light. This is also really useful if you're not sure which object it's linked to. You can click on this field here and it will highlight it in the hierarchy. Be like, hey, maybe I have, a whole bunch of directional lights and they all have the same name. And I'm not sure which one I'm linked to. They're shuffled around for some reason. But now I can just click on it and say, okay, this script is linked to this guy, and I can start dealing with this stuff here. Yes, exactly. Sometimes the names will be the same, especially if you're creating things during runtime. It's easier just to leave things with the same name. But I would say as you're building a level out, it's better to name things well. Yeah, exactly. Good naming is really, really important. If I delete all of these objects, okay, the delete keys apparently don't work on this keyboard. Now you can see that the target is now missing. We've deleted this game object. It's saying, whoa, I used to have something, but it's gone now. So I'm going to create a cube, and I'm going to link my cube to this target. And let's rename this game object to linkage practice. It's not law, but I prefer to have my game objects with the same name as the script on them. That just makes it really easy for me to look in the hierarchy and be like, oh yeah, that's where this script is. Things can get a little confusing when you have like 10 or 15 components on the same object. It does happen. Player objects are generally pretty complex. But I think in this class we're gonna keep it nice and simple. It should be good. So what's a good way to say this? What was that movie where they kept going inside the dream? Inception? Yeah. So we're going to, or I will show componentception. This is not a real term. I just made it up. But the idea is that a component, whenever we create a new script, this component is now a type. Oops. And that means we can use the type like any other type. Game object, float, bool. Well, we have a linkage practice. That means I could have a public linkage practice object in here. And I could say this is linkage reference. So you don't only have to link to game objects, you can link to any component in the world. I could have a public light. Directional? No, I think it is light. So any component that exists, even our own that we make, we can have links to them. And Unity is pretty nice about this. So these two pop up like we'd expect. And here it says, this is the type I'm looking for. I'm looking for a linkage practice. If I try to drag main camera over on here, it's not going to let me. Main camera also doesn't have a light component attached to it, so I can't drop it in here either. I can drag this directional light onto here, because if we look, our directional light has this component. So not only do we have the ability to link to entire game objects, like we did with this cube, we can link to specific components on those game objects. So let's see. Let's pretend this is the inspector. We've got our variable name. And what happened when it's empty? Okay, so if we don't have anything attached, it will say none, and then the type that it's looking for. So if something is not linked, it will look like this. None or maybe missing if something has gone wrong. I love that Photoshop has these automatic straight lines. That is super cool. There should never be a C# file in the hierarchy. Oh, this is just a game object that I named the same name. Yeah. This could be Wargarble, and it would work just fine. Good question, though, yeah. It's a little bit confusing, but... Oh, right. Should I make the text bigger? I see some nods. Okay. Uh-oh. This will be fun. How? View options, maybe? Icon size, grid spacing. System preferences. Display. Which one? I don't think Unity... Well, maybe it does on Mac. No. Last time it was my own computer, and I was using Windows, so I was able to do that pretty painlessly. Yep. We'll ask the entire the accumulated knowledge of the human consciousness. I don't know, it's not text size, it's interface size. System font size, that seems right. It turns out OS X may not offer a method can adjust their screen to increase. System preferences display. Next to resolution, check scaled. We were so close. We were so close.